Okay, let's carry on. Let's discuss the instantaneous center of zero velocity, this IC. This instantaneous center of zero velocity on this bicycle or this wheel, for example, is the point in contact with the ground, so it doesn't move. The velocity direction at any point on the rim, يعني على المحيط, is perpendicular to this line connecting this point to this instantaneous center of zero velocity. يعني هذه zero velocity النقطة هني on the rim, the instantaneous velocity is perpendicular to this. It's perpendicular to this line. It's perpendicular to this line. نستخدم اللون الأحمر أحسن. So this is the line and this is perpendicular to it. This is the line from this point to this instantaneous center of zero velocity, and this is perpendicular to it. So the maximum velocity طبعا راح تصير هني at the top where this is the maximum. As we'll see, we'll use the radial velocity formula, and this is proportional to the radius, so the r vector, so to speak. Okay. What about the application? Well, sliding board or sliding ladder down a wall can be used to demonstrate this thing. This moves down and this moves to the left. So you have ways to analyze these motions. We can use this to analyze motion of other similar situations, and we'll look at the motion of the center of gravity of this thing. So it has to do with the resultant of these 2 points. For example, let's analyze this in detail. One second. So the instantaneous of zero velocity for anybody undergoing planar motion, there's always a point in the plane of motion. يعني this thing, it has an x and a y, and the plane of motion is the x and y plane. So this plane of motion is what we mean, the xy plane, إذا هذا x وهذا y, where at which the velocity is instantaneously zero. So the velocity of this point is zero. هني, for example, when this is rotating, the velocity of this point in the middle is zero. هذا goes with a certain velocity, هذا goes with a certain velocity. So قاعد يدور actually move بالنص somewhere هني. Okay. So the velocity of this point is zero. It's called the instantaneous center of zero velocity. This point is called this IC, and it may not occur ولا lie on the body. لما هذا قاعد يفتر هني, it could be on the body. It could be outside the body. If this is fixed, it could be on the edge. So this is going this way and this is fixed. So this is the IC, the instantaneous center of zero velocity. Or it could be outside. This could be outside. هذا قاعد يمشي بهالطريقة وهذا قاعد يمشي بهالطريقة. This is lower velocity. So كلهم they are rotating about this point which is outside the body. Or it could be inside the body but not along perpendicular lines من هذيل. So this is perpendicular line, this velocity, this perpendicular line to this velocity, they're connected. It might be a different situation. So this goes this way and this is the perpendicular line, and this goes this way, this is perpendicular line. They meet هني and their cross, the intersection is the instantaneous center of zero velocity. So a small note, if the location can be determined, the velocity analysis can be simplified because the body appears to rotate about this point at that instant. قاعد أقول إن the body is rotating about any of these centers of constant of zero velocity. How do we determine this point? We can locate it in a few simple steps. To locate it, we use the fact that the velocity at a point in the body is always perpendicular to the relative position vector from the instantaneous center of zero velocity at that point. البوسيبيليتيز اللي قلبناها هذه واحدة منهم، إن البوينت lies velocity of this point A on the body and angular velocity of the body are known. هذه أول طريقة. مثلا هني عندك ال instantaneous center of zero velocity and the velocity of the point on the body as well as the angular velocity omega are known. So هذا the first situation. In this case, this is located along the line drawn perpendicular to VA. The line perpendicular to VA at A, at the point A. Note that this lies up and to the right of A. Up and to the right of A, since A must cause a clockwise angular velocity. So this is positive, this is positive, so this thing goes this way and goes up and to the right. So clockwise angular velocity about this IC. هذا الحالة الأولى. الحالة الثانية happens when the line of action of two non-parallel velocities, VA or VB, they are non-parallel, are known. So مرة you know the velocity and omega. Another time is you learn two velocities on the body and without knowing the angular velocity. This is not known. So you construct a line between this instantaneous center of zero velocity that crosses this and crosses this, and التقائهم هو اللي راح this is perpendicular to the velocity and this is perpendicular to the velocity. You extend them until they meet and then you have your IC point. So construct line segments from A and B perpendicular to these velocities, and the point of intersection is where the IC lies, so on the body or outside the body. The third and final method to locate this IC point is the magnitude and direction of two parallel velocities at A and B are known. فما عندنا نفس الحالة. They will not intersect. They will never intersect. ليش؟ لأن they are two parallel lines. So the location of IC is determined by proportional triangles. So عندي هذا parallel, they will never interact ولكن they will never intersect, ولكن عندي هذا المثلث وعندي هذا المثلث الثاني. So I can deduce location of this IC. طبعا إذا هذيل ما يسوون مثلث، إذا يسوون مستطيل, I know in this as infinity and this is just rigid body motion without rotation. We'll come to that in a second. This is the special case. Note that if the body is translating only يعني VA is equal to VB كلهم قاعد يمشون بنفس السرعة, then we would have this instantaneous center of zero velocity will locate the infinity and the omega, sorry, W, the omega is zero, no rotation. Now, to analyze this situation, let's look at the velocity of any point on the body undergoing general plane motion. So general plane motion يعني فيها translation as well as rotation. So they can determine this by scalar approach, two approaches. And then a scalar approach, once the instantaneous center of zero velocity is located, we can use these as scalars. We sum over each direction. قلنا بالX والY والZ, الJ والK والI والJ والK, we isolate them and we solve whatever unknown we have. مثلا, since the body here seems to rotate about this IC at any instant, the magnitude of the velocity of any arbitrary point, مثلا A, can be done using the regular formula. So this V is rotational velocity, angular velocity times the relative position. So this is not an absolute position. You notice in there it's not RA, ولكن it's RA in relation or relative to this IC point. We will carry this for these type of analysis. You'll see them often. So this RA/IC relative to IC. نفس ما هذه, this thing is RB relative to instantaneous center. So where r is the radial distance from IC to the point going this way, and this is going this way, and this is going this way, الاتجاه يعني positive. The velocity line action is perpendicular to this associated radial line. So this radial line هذا perpendicular, this guy is perpendicular to the velocity, and so on. As an example, let's say you have a linkage here undergoing motion as shown. أنا هذا مربوط وهذا محكوم, doesn't go back, وهذا you cannot penetrate this, but this goes in the x direction with a given velocity v. So this is vd. It has this direction. So this is 3 meters per second, and we want to find the angular velocities of links AB and BD. So what is the angular velocity here and the angular velocity here? Omega or omega. So the plan is to locate أول شيء the instantaneous center of zero velocity of this link, and عندنا velocity مالته, and then solve for the angular velocities. You notice على طول إنه this is const هذا بالAB, we'll come to it, إن هذا this is constant, إن هذا مثبت هني, وهذا pure rotation about this point. هني هذا has a given velocity. So this velocity is easy to relate it to this guy using R هذه. بس R المشكلة إن هذه قاعد تغير. ولكن ما لنا شغل لأنه like we said before, it's relative to the instantaneous center of zero velocity. Let's look how this can be solved. And like I said, since point D moves to the right, it causes link AB to rotate clockwise. So this we know this about a point A. So the instantaneous center of zero velocity for BD is located at the intersection of line segments drawn perpendicular to VB and VD. So إذا هذا يمشي كذي, and you have perpendicular to it as a line this way, and B is going this way. I have to throw it this way. So B is going this way, and this is the line perpendicular to it. So بالنهاية هذا الIC. So we have some information about this لأن هذا محكوم, هذا radial, هذا ما يتحرك. Note that VB is perpendicular to the line AB, therefore we can see that the instantaneous center of the velocity is located along the extension of this link AB, along the extension of this AB. Okay, يعني مطلوب. والمطلوب نقدر نشوف أول شيء BD, هذه أول وحدة, عندنا R وعندنا الangles, لأن we are given that we want to solve it when the angle is 45 degrees و 45 degrees. يعني نفس ما قلنا velocity can be related to the angular velocity. V is omega r, but before that we have to determine R's نفسهم. So V, this guy, so V is equal to omega r, معناته الأوميجا is equal to V divided by R. ولكن R's ما عندنا. شنو R؟ ولا R B is the distance. هذا if you look at the triangles, so if this is 45 and this is the hypotenuse, and this is the opposite, and this is the adjacent. So tan is nothing more than the opposite divided by adjacent. So this is 0.4 اللي هو length مال هذا times tangent مال هذه. Okay, so tan 45 is هذا opposite, so RB in relation to relative to IC divided by الأخ هذا اللي هو BD. يعني باختصار this R B over IC أو relative to IC اللي هو راح تصير عندنا BD times tan 45 اللي هو هذا. نفس الطريقة ال RD with respect to position of RD with respect to the instantaneous center is given by نفس الشيء الكوساين وال let me draw it again. بالنسبة ل D هذه D position D is equal to I'll say tan or cosine actually of this 45 degrees is equal to adjacent times overall hypotenuse. So this is RD slash IC divided by hypotenuse اللي هو BD معناته this guy is equal to cosine times BD اللي هو 0.4. So this is how we get R's. Brush up on your trigonometry. Now, once we have these R's, we could write just the definition of velocity in terms of angular velocity. So since this is known, the magnitude of V is known, all that remains is the angular velocity. So the angular velocity is this. Now, we have to realize حق الثاني, we want the angular velocity of this and of this. So as the AB link is subjected to rotation about A, we know the angular velocity of this is VB relative, divided by R نفس ما سوينا هني. Okay, so ولكن VB نفس ما كتبنا فوق can be written in terms of the position of B من هني and the length of this. So let me write it explicitly. هني إذا قلنا equation هني قلنا إن VD is nothing but omega BD. I'm talking about for this link RD طبعا relative to IC. In the same way, I could say BD VB عفوا is omega omega BD times RB relative to IC. So من هذه أقدر أقول إنه VB آخذ هذه وأحطها مكان هذه. So this will be reduced to RBIC relative to IC times ED اللي هي هذه بالضبط divided by شنو؟ divided by RB. So I mixed and match, خذيت معلومات من BD and استخدمتها عشان هذه. And when you substitute تلقى إن هذا 5.3 وهذا 5.3. So rotation is the same. حتى لما تتخيلها بتشوف إن هذا rotates this way وهذا rotates this way with the same angular velocity. Another example related to a gear. نفس الشيء هذا has a certain rotational velocity and this has certain linear velocity in the x direction, and I'll let you look at it on your own. Let's look at a couple of concept questions. Number one says, if applicable, the method of instantaneous center of zero velocity can be used to determine the blank of any point on the rigid body. ما يبيلها يعني تفكير. instantaneous of zero velocity يعني velocity. So the answer is A. لا acceleration ولا force ولا يحزنون. Number two, the velocity of any point on the rigid body is blank to the relative position vector extending from the IC tiny center of zero velocity to the point. So عندي vector R and the velocity ايش قصتها هذه؟ هل هي always parallel, always perpendicular ولا in the opposite direction ولا in the same direction؟ هذا اللي نرسم الزاوية القائمة. So it's B always perpendicular. السؤال الثالث when the velocities of 2 points on a body are equal in magnitude and parallel قاعد يمشون نفس الاتجاه but in opposite direction عفوا يمشون اتجاه المغاير ولكن equal. So the IC is located when infinity will one of the 2 points. The classic case of rotation العادي. Well, and the answer is at the midpoint of the lines connecting the 2 points. هذا كنا pin وهذا قاعد يمشي بهالطريقة وهذا يمشي بهالطريقة. One of the special cases that we looked at. Number 4, when the direction of velocity of 2 points on a body are perpendicular to each other. The IC, the instantaneous center of zero velocity, is located at infinity. طبعا لا. One of the 2 points لا لأن one of the 2 points راح تصير واحدة zero وواحدة قاعد circling around it. The midpoint الكيس اللي فوق طبعا لا. So that leaves us with none of the above. And السؤال الخامس, the wheel shown has a radius of 15 inches. Again, sorry, مخلفات آخر مرة درست الكلاس. And rotates clockwise at a rate of omega 3 radians per second. What is VB? Well, it's a simple relation. أنا شغل بالunits. And 3 times VB. So this is the velocity. So the answer is 15 inches per second. And lastly, question 6, point A هذا اللي تحت on the rod has a velocity of 8 meters per second to the right. Where is the IC for the rod? So الرod قاعد ينزل عفوا قاعد ينزل بس it's rotating counterclockwise. هذا قاعد يمشي إلى اليمين وهذه probably قاعد تمشي إلى تحت. So if you do it هذه تمشي كذي and this is perpendicular. هذا اللاين اللي perpendicular وهذه تمشي كذي. هذا اللاين اللي perpendicular to this guy. So the intersection is this way. So point C. Okay. We'll do these couple of problems بالclass once I'm back. So these are really nice problems. 2 examples من الchapter. Let's move now to acceleration real quickly. So we looked at velocities, and let's look at the angular acceleration and its relation to the linear acceleration. So in the mechanism of this window, for example, هذا اللي تنفتح وتنصك. So the link AC, this guy, rotates about a fixed axis through C, and AB undergoes general plane motion اللي درسناه. Since point A moves along a curved path, هذه كذي من هني تروح كذي إذا كملناها يعني كذي. It has 2 components of acceleration, while point B, sliding straight track, has only one. هذا B is not doesn't rotate. So one component of acceleration. These components of acceleration of these can be inferred since their motion are known. So we want to know how to determine the acceleration of these links in this mechanism. Another example is this piston thing in a cylinder. So this piston moves up and down linear هني, or this camshaft, this crankshaft of a car. This has acceleration and velocities in the circumferential direction as well as in the translating in the absolute up and down y direction. So this is automated engine. The forces delivered to the crankshaft and the angular acceleration of the crankshaft depend on the speed and acceleration of the piston. كل ما صار هذا سريع كل ما أعطاني more power in the crankshaft. السيارة be transferred using gearbox إلى tires. So how can we relate this acceleration of the piston to the acceleration and power delivered to the wheels? Let's look at motion and the acceleration involved in it. First, let's look at the equations relating acceleration of the 2 points on the body determined by differentiating the velocity equation. So dv dt وبعدين dv dt dv dt هذه relative velocity of point B relative to point A. So we know this and we'll use some calculus to do this. These are absolute accelerations. dv dt يعطينا accelerations. These are absolute of these points A and B. So they are measured from a set of fixed X and Y. ما لها شغل. It's not relative, no relativity. ولكن this component is the acceleration of B with respect to A, and it includes both tangential and normal components. And في possibility in a point B rotates about point A. So بالإضافة إلى النورمال في عندنا tangential. The result is the acceleration of B is equal to the absolute acceleration of A plus the acceleration, the tangential component of the acceleration of B with respect to A plus the normal component of the acceleration of B with respect to A. So we're accounting for both components. Graphically, this is how we draw them. So the acceleration of B is this absolute acceleration of A, of point A. أنا شغل أي شيء ثاني بالإضافة إلى tangential component of the acceleration of B بالإضافة إلى normal acceleration of B with respect to A. هذا normal along this axis اللي هو normal axis. وهذه طبعا translational acceleration of point A اللي قلنا عنها. So the relative tangential acceleration component is acceleration in the angular sense. So this is the angular acceleration across product with a position vector of B in relation to with respect to A, and perpendicular to RB with respect to A. So this is the absolute the magnitudes. You can determine them by determining the vector form and then getting the magnitudes from this number. So the relative normal acceleration component, normal tangential, is just what we have for the particles. If you remember, this is the velocity squared divided by الرو radius of curvature. هذا يقوم مقام الراديوس of curvature ولكن in vector form. وهذه velocity square لا هذه angular velocity square. So the normal component of the acceleration, if you have rotation of B with respect to A, is minus the omega, the angular velocity squared with a minus outside, times the relative position of B with respect to A. And the direction is always from B to A, from B towards A, from B towards A, from B towards A. Other component in normal, like we've seen in the particle, the first 4 chapters. Let's look at the acceleration again. So these components يعني بالتفصيل. This is the angular acceleration. نفس ما كان هذا الانgular position theta وبعدين عندنا omega وبعدين عندنا alpha. So this is my alpha across with the relative position of B with respect to A, and the normal is minus قلنا minus minus omega square relative position like we said on the previous slide. So the relative acceleration components become عندي هذا وعندي هذا وعندي هذا. Note that the last term in the relative acceleration equation is not a cross product. هذا مو cross product. هذا vector وهذا سكيلر. ما يصير احط فيكتور، هذا ما يصير احط الفيكتور مع فيكتور يم بعض والا بيعطيني شيء called tensor. ما نبي tensor. Tensor looks like a مو vector, it's like a like a matrix. ما نبي هذا. So this is just a scalar. هذا a cross product of a vector with a vector will give you another vector. وهذا vector خلقه بروحه. So vector 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 will give you a vector. No scalars in this equation and no tensors. We don't know about tensors. Yes, we haven't studied tensors, بس إنه يعني vectorين يم بعض will give you a tensor. Forget about this. المهم إن note إن this is a scalar. If the product of scalar square of the magnitude of this angular velocity and the relative position of this will give you result in a vector still. What about the relative acceleration equation? Well, in applying the relative acceleration equation, the 2 points used for analyses اللي هو A will be, let's look at the examples we did. هذا الكتاب يشرح باستخدام هالexample. So we'll stick with it. Should generally be selected as points which have known motion. So A will be أنا أدري إن هذا fixed known motion. وهذا عنده angular velocity ما عنده radial velocity. So no radial components هني, which is nice and simplifies the analysis. Pins, connections, and other with other bodies هذول are nice points to select. لأن we have known motions. And this mechanism اللي هني shown in the picture, point B is known to travel along a circular path. It's not extending. إذا هذا extending ولا contracting تعقد شوية المسائل شوية. So AB can be expressed in terms of its normal and tangential components. AB. واحد منهم يسهل. Note that the point B on the link will always have the same acceleration as point B on the AB link. So this point will have the same acceleration as point B on the link AB. So أقدر إذا طلعتها من AB أخذها نفسها وأحطها BC. هذا will have the same as point as this. Point C, on the other hand, connecting BC and the piston moves along a straight line. هم هذا سهل على نفسنا. So this has all the examples that you could think of. Straight line. So straight path. So AC is directed horizontally. Okay. So these are some comments on the acceleration. This is what you use. This is a procedure we should use for the analysis to make it simpler on ourselves. So establish a fixed coordinate system. مو كل مرة تقلب مرة X ومرة Y هني ومرة تفرها بحسب السيجمنت اللي عندك ومرة تسوي like spherical ولا cylindrical coordinate system. Just stick with X and Y and for known ورسمه. Okay, like in drawing the free body diagram, just draw your X and Y so that you don't change them. And then know your kinematic diagram, draw your kinematic of the body. هذا goes this way وهذا في acceleration in this direction. هل constant ولا مو constant. طبعا هذا vector and so on. And indicate شنو هذيل. Indicate هذيل on the figure, on the kinematic diagram. بعضهم أصفار حطهم وقول إن هذا صفر. So if the points A and B move along curved paths, then their acceleration should be indicated in terms of the tangential and normal components. إذا عندك أشياء curved path. إذا straight path بتقول له والله واحد منهم مثلا. Apply the relative acceleration equation. ما عندنا غيرها. We have 3 components, 1, 2, 3. If the solution yields a negative answer for this unknown magnitude اللي you're after, then your initial assumption is wrong من ناحية direction, and this vector is in the opposite direction to the one shown in your kinematic diagram. For example, let's look at this example. Let's look at this example. It's a simple rod AB that has an acceleration of 5 meters per second, and and a velocity of 6 meters per second. So this point A, we have these مو angular values ولكن absolute x and y direction. So this is minus 5j نوعا ما if this is the x and y عشان ما نتخربط, and this guy is minus 6j meter per second. كلهم جايين بهالطريقة. We want to find the angular acceleration of the rod, this AB, and the acceleration at point B at this instant. Which instant? لما يكون this is 4 or this is 5. طبعا this is 3, 4, 5, so this is 3 meters. Just by not going through trigonometry, this is a 3, 4, 5 right angle triangle. And we want to find these two things, the acceleration here. We want to find the acceleration of this rod. Okay, so what can we do? We'll write أول شيء طبعا we'll write the angular velocity of this rod. Let's assume in this is the angular velocity omega and this is the angular acceleration. طبعا من البداية نشوف إنه this is rotating in the opposite direction, but let's keep it this way. Okay, so let's say إنه this is the angular velocity. What we use relative to the instantaneous center of zero velocity. So this is VA, position of R with respect to the instantaneous center of zero velocity, and this guy is 3. It's 3, and this gives you 2 radians per second. Now we have this omega of the rod. Since A and B are both move along straight lines, just one component. So the acceleration of point A is minus 5 meter per second, minus 5j meter per second لأنه نازل, and the acceleration of point B is in the positive I direction. Positive I direction و negative Y direction بالنسبة ل A. So we write the equation اللي ما عندنا غيرها. So AB is equal to AA plus الألفا اللي هي angular acceleration crossed with the relative position of B with respect to A, and then minus the omega square اللي تم طلعناها, and again the relative position of B with respect to A. The relative position of B with respect to A is شنو البوزيشن مال هذا؟ this well بالنظر راح أشوف إن this has to go 3 in the X direction, we have to go minus 4 in the Y direction. So this guy is 3I minus 4j. This 3I minus 4j. And if this is rotating this way, if this is rotating this way, طبعا هذا positive لأنه in the positive direction. لكن الألفا, I have no idea. Is it slowing down? I know إنه if this goes لهني والرود كذي بينسدح راح تكون هذه كلها مصفرة, ولكن يمكن you might be able to tell إنه من positive it has to have a negative value عشان تصير صفر. So I'm gonna keep this as positive, absolute value مال هذه in the X direction. So this is a right hand rule. This is out of the page. I'm going to assume it's out of the page. We'll talk about this if you're not sure what I mean بالنسبة للdirection. بس إن I'm going to assume إن this is alpha k. وعاد اللي يطلع لي اللي يطلع لي. I sum this and يطلع لي equation فيها I و J من ناحية acceleration of point B. So I substitute everything and I get this, and أضرب 2 هذيل 3 والى اخره الى اخره، يطلع لي شنو؟ يطلع لي هذا unknown وهذا unknown. شلون I solve it؟ والله I compare الكومبوننتس. الاي شنو؟ القط الايز هذه وهذه وهذه، راح يطلع لي ان ال AB is equal to this، وهذه الايكويشن مالت الجي. هذه one unknown، so الأوميجا من alpha is given by this، و I substitute it in this equation ويطلع لي ال AB. نلاحظ أن الألفا is in the negative direction، so عكس اللي أنا متوقع، رسمتها كذي بس هي actually negative direction، بس ما يهم. Let's look at relative acceleration analysis where we have two bodies in contact. So سواء ground and some rolling body ولا two bodies like two gears مثلا. So let's consider two bodies in contact with one another without slipping. Important إنه without slipping لأن we will equate the tangential velocity, tangential acceleration at the point of contact to be the same. So without slipping implies in they are the same. So I might ask you in an exam with a quiz شنو هذا means، شنو بالضبط. Where the points in contact move along different paths. So هذا البوينت مالت A قاعد تمشي بهالطريقة وهالطريق، وهذا قاعد تمشي بهالطريقة. So يفترقون نوعا ما، بس instantaneously they are the same. They have the same thing at point T. نلاحظ أن في هذا changes direction، goes from this direction to this direction to this direction، وهذه العكس تروح كذي وتروح كذي وتروح كذي. So in this case the tangential components will be the same، يعني point A point of contact هني tangential component of the acceleration is equal to point A prime. هذه tangential component of the acceleration. Let's use this. هذه A وهذه A prime، والpoint هذه they have tangential components، they are the same. Which implies that هذه nothing but this is nothing but alpha times RA RB والRC من هني وهني. So the normal component acceleration will not be the same، لأن هذا يعتمد على R وهذا تعتمد على R، and these components will not be the same. Only the tangential where they meet. So the total acceleration will not be the same. Okay, so we know that. We can apply this to rolling motion, also a special case. Another common type of problem encountered in dynamics involved rolling motion without slip. The key is without slip. So balls, cylinders, discs, and whatnot, rolling without slipping. So this situation can be analyzed using the relative motion and relative velocity and acceleration equation. So هذا rotates with a certain omega, and this is the point of contact. And you have a radius between G, the center of the body, and A, the center of the contact point. معناته عندنا normal direction وعندنا tangential direction perpendicular to each other، وعندنا relative position of G, this point G with respect to A, the point of contact. And you have a velocity in the y direction, Cartesian for component, and you have an angular velocity. And you have an angular acceleration as well, and you have a Cartesian components of the acceleration A as a function, طبعا vector, as a function of the point G. So A G هذا vector طبعا، هذا vector وهذا كلهم vectors. Acceleration of point A has two components. أول شيء acceleration in the x direction, acceleration in the y direction, and tangentially you have this. Let's zoom out and carry on. As the cylinder rolls, point G يعني center moves along a straight line if omega and alpha are known, the relative velocity and acceleration equations can be applied directly to A, and they are related by R. At the instant A is in contact with the ground. Many of the problems بتشوف ان A تمشي هني وتمشي هني وتمشي هني بعدين تحوش لجراوند وتقول at this point ويعطيك values for these. At this point, what are the angular acceleration? What are the acceleration of point G and all that. However, this is not a point of zero acceleration. As we rotate, ما يصير. في rotation ما يصير zero acceleration. Let's look at velocity equations will acceleration equations. Since no slip occurs معناته velocity of A is at point A is zero. هذه ثابتة with respect to the ground. So هذا what it means to have no slip. الجراوند ثابتة معناته wheel point, this point on the wheel the disk is ثابتة. So this is 0 when A is contact with the ground. From the kinematic equation, I know in Vg velocity مالت هذا is equal to Va plus إذا هذا 0 طبعا لأنه no slip plus rotation component. So the angular velocity of point G relative to point A. So angular acceleration, angular velocity is minus k. So هذا this goes in the positive direction out of the page, or this goes into negative out into the page. This is minus omega crossed with R. يعني basically Vg is equal to omega R. Or in terms of vector quantity, so Vg is omega R I. Since G moves along a straight line, AG is horizontal. So just before A hits the ground or touches the ground, its velocity is directed downward. هذه هني وقاعد تنزل كذي. And just after it contacts with the ground, the velocity is moving upward. So عندنا شوية change in velocity direction معناته change in acceleration. So at point A accelerates upward, it leaves the ground, you'll have a negative acceleration. Negative acceleration. So الequation مالت acceleration A acceleration مالت G is equal to acceleration مالت A اللي هي مو zero anymore. It's not zero anymore. Plus alpha crossed with relative position of G with respect to A minus طبعا هذا الماينس هو كذي خلقه omega squared R الفector G with respect to A. So هذه عندنا R اللي هي minus J لأن هذا ال R عبارة عن minus J negative direction and you have I's و J's و K's. So evaluating each of the I's و J's و K's, you'll have this as هذا في unknown و unknown و this وفي unknown و unknown وهذا وهذا. So I have 3-4 components of 3-4 equations تشوف شنو ال given وشنو ال missing. Let's look at this example. It's a simple example where the gear with a center O rolls on a fixed rack. معطيني الانجل acceleration والangular velocity. So this is 6 radians per second square وهذا 12 radians per second. And you want to find the acceleration of point A. Acceleration of point A يعني شنو؟ يعني A. بس معطيني هذا. The angular acceleration of the disk. So we want to follow what we know. We write the equations one by one. So since the gear rolls on a fixed rack without slipping, O is directed into the right and it has this magnitude. This is alpha times R. This is the magnitude. So this is 1.8 meter per second square. لأن هذا معطيني 6 وهذا 3.3. So I'll know this is 1.8. Okay, so this is out of the way. Now, with this value, we can apply the relative acceleration equation between points O and A. So the big equation عندنا الطريقة هذه. I want this and I have done this. Okay. وعندنا acceleration crossed with the position, and we have acceleration عندنا اللي هو 1 point معطيني إياها and R this is 0.3 لأن radius 0.3 والماينس عبارة عن this is square 12 squared لأنه معطيني velocity الأوميجا and R again 0.3. So this is my acceleration of point A. You look at this at your own, and maybe we'll talk about it in class بعدين. Have two more examples. I'll probably fly out in an hour or so. Let me upload this and see what we can do next week. And I'll do more problems من الكتاب over the next couple of days, and I'll upload them as well. Okay, have a nice weekend.